Again, welcome to CS628 class, Data Science. This lectures cover the vectors and matrix operations using the Python NumPy package. So this also covers our week 5 assignment, which we use the NumPy package to solve our problems. So first, NumPy is a computational library that helps in speeding up vector algebra operations that involve vectors and also matrices. For example, finding the distance between 2 points, or cosine similarity, or doing a matrix operation such as arithmetic or transpose, etc. So NumPy is extensively used in the domains of data analytics and also machine learning, because we know, again, data science, machine learning involve processing data and try to find the patterns in data. So NumPy can play a bigger role on it. So the first thing we do always is to import the NumPy package before we can use it. Now, in this case, I'm using the Jupyter. You can either use the Jupyter Note or the Jupyter Lab. In my case, I'm using the Jupyter Lab. So I click on the launch and I already have it here. So this is my Jupyter Lab. So the first thing I do, I import the NumPy as NP. Then the first thing I did here again is to create a vector with 10 values, and all the values are 0 because I'm using the 0 function. So np.zeros and 10. So it will create a vector with, again, 0 items. Now, in this case, after I create a vector with 0 items up to 10, I assign 1 to number 4, which will be the 5th element. So this 4 here is called the index of the vector or the array. So normally the index starts from 0. So the first item is 0. So the 5th item will be index number 4. So when you look at the result here, later we print the Z. So when we look at the Z result here, we have 0, 0, 0, 0. The 5th element is 1 because we assign 1 to 4. Then the rest are 0. Now, using the zeros function, we can create a vector with 0 elements. Now, with the assignment operator and the index, we can assign any value. And this doesn't have to be only 1. For example, I can assign 20 to the 3rd value, which in this case will be Z2, 0, 1, 2. Then we print it. Now, after I write this code finish, I'll press the run or the right arrow here, which will be our run button to run it, and I'll get the output. So next, again, I use the I function, and also to create again, I function will create identity matrix. So you can see here we say I3, which means we are creating a matrix. The size is 3 by 3. And then we can see the diagonal values are 1 throughout. So normally in mathematics, we call this as a diagonal matrix. And here also we call it identity matrix. So most of all the functions we shall see here, all the operations, again, I use the Jupyter Lab. So as we said, the first thing we import the NumPy as NP. Again, the name can be any name, but I'm using NP. By default, most textbooks all use NP. So here we say np.zeros, 10, we assign to Z. So this means I'm creating a vector, again, with 10 elements, and all the elements are 0 because we're using the zeros function. Then later we use the print function to print the content, which gives us zeros. Now, the next question said how to find the memory size of any array. So in this case, to find the memory size of any array, we use the size. So the array name is Z again. So we say Z.size times Z.item size, or asterisk Z dot item size. This will give us the size. In this case, we have 10 by 10, so it will be 800. Remember, 1 byte is 8 bits. And also we have the unit for integer. This is a whole numbers. So we have to know the size of each unit. So the next one also is we use the zero function again. We are creating 10 elements in the vector, but we assign 1 to the 5th element. Then we print it. Next, we create a vector with values ranging from 10 to 49. So here we make sure that the vector that we create, the values are between 10 to 49. So we start now, we saw this when we are using the range function, even the range function. So if we said range 10 to 50, it will go up to 49. And the same thing if we use arrange also. So we have arrange is a function in the NumPy package. So here we say np.arrange 10, 50. Then we print the z. So we can see that this will print all values from 10 to 49. Now, if I want to print from 10 to 50, then I'll say 10, space 51. Then it will go 10 to 50. It's the same as using the range function in the for loop. If we say 10 to 20, it means I'll go from 10 to 19. Next, we are writing a short code to reverse a vector, which means the first element becomes last. So here also we say np.arrange 50. So what we are doing, we are generating values from 0 to 49. Now, if I print this arrange, we have np.arrange 50 z, and I print the z, then I'll get values from 0 all the way to 49. But we want to reverse it. So here we have the vector name, square bracket, and we use the 2 colons and -1. So this gives us the idea to reverse. So we start from, instead of starting from 0 to 49, we start from 49 to 0. The next is to create a 3 by 3 matrix with values ranging from 0 to 8. So this means we're still going to use the arrange function. Now, since the value will be from 0 to 8, then we are going to use 9. Here, since the values will be 0 to 49, we use 50. But this time, we have 3 by 3 matrix. So we use the function reshape 3 by 3. The reshape will take the size of the matrix. Now, the size is again 3 by 3. So we can see there, when we print the z, this will be the output. Remember, arrange gives us 9 values from 0 to 8. So we start from 0, 1, 2, 3, 4, 5, 6, 7, 8. So arrange gives us the values, and reshape the matrix size. And so next is to find the indices of a non-zero element from 1 to 0040. So what we mean by index is the positions and the position of each element or values in the vector. So for example, 1 is in the position 0, the index is 0, 2 is in position 1, 0 is in position 2, another 0 position 3, etc. So net index always start from 0 to the size -1. So if it's 10 element, it will be 0 to 9. Here we want to find the indices of non-zero values. So we are going to get the index 0 and 1, 2, 3, and the next one is 4, which is, so this 1, 2, 4, we are going to get their index out. So in order to do this, we also said np.non-zero. Remember, we use zeros to get, again, create a vector with 0 values. So we can use non-zero. This time the argument is, again, the vector that we have here. So this will give us the indices of all the non-zero values. So here, when we set np.non-zeros with the vector as the argument, the result we get, we assign it to a variable named nz. then we print the content of NZ. So this should give us 0, 1, and 4. So the answer is 0, 1, and 4. So this 0, 1, and 4 is the index, which is the position of the values in the vector. Next, they say we should create a 3 by 3 identity matrix. Now, identity matrix, also called diagonal matrix in mathematics, is a matrix that all the elements values are 0 except the diagonal section, which is 1. Now, in Python, NumPy, we use the function I. So here we have np.i3. So this will create an identity matrix. Now, identity matrix always is a square matrix. A square matrix is a matrix that the number of rows is the same as the number of columns. So the I here, we take only one argument. So if it's 3, it means 3 by 3. If it's 4, it means 4 by 4. Then we can print the Z. Now, identity matrix, as we said, always on the diagonal section, the values are 1. The rest of the elements are 0. Okay, so next we are going to create a 3 by 3 by 3 array with random values. So again, this is like a 3-dimension. We can see the result here. But first, let's go through the code. So we know in Python already that if we want to create a random values, we use the random class or the random function. So here again, NumPy, we say np.random.random, and is the size 3 by 3 by 3. So we have 3, 3, 3. And then we print it. Now, when you are using the random class in Python, and you didn't specify the random values range, it always gives you a value between 0 to 1. I would say excluding. It won't give you 1, but it will give you 0 to up to 0.99999. So 0.001 to 0.9999. So excluding the 0 and the 1. So here we can see that the size again is 3 by 3 by 3. So our first section, you can see that we have 3 by 3. Then we have another 3 by 3, 3 by 3, because it's 3-dimension. And you can see that all the values are between 0 point something to 0.99999. It doesn't reach 1. So we use again np.random.random and the dimension and the size. Next, they say we should create a 10 by 10 array with random values and find the minimum and maximum values. So we can see this is the same as the previous one. So we use np.random.random. This time is 2-dimension, 10 by 10, 10 by 10. So we have 10 and 10. After that, we can just print the Z. When we print the Z, it will give us 10 by 10, which will be a lot of values. 10 sets, 10 by 10 set, and 10 by 10 set. So, 10 by 10 sets of numbers. But here, our goal is not to print all the values, but we want to print the minimum and the maximum values. So we use the main function to get the minimum value from the numbers that we generated for the array 10 by 10 size. And also we use the max function to take the maximum value from the same array that generate the random numbers size 10 by 10. Then we assign the two values to a variable named zmin. So zmin, we take the value in z.main function, and zmax, we take the value from z.max function. And now we want to print only the zmin and zmax. So the minimum value is what is here, and the maximum value is 0.9946, etc. Now, if we want to print everything 10 by 10, then we can just print z. So we can add print z, and that will print everything. Next, also, we have to create a random vector of a size 30 and find the mean value. So we create, again, we use np.random.random. Again, the size is 30. So this is a vector, 1 row, 30. This is a matrix, or I would say array 10 by 10, 2-dimension. So When we create it finish, here we just want to print only the mean, so we don't need to print all the 30 values. But if we want, we can say print z as argument of the print function, and it to print all the randomly generated 30 values. But here what we did is after we generated the 30 values, we assign it to z vector. Then we find the mean of all the elements in the z vector, and we assign it to m, and we print it. So the mean value is what is here, 0.4835, etc. Next is how to find the common values between two arrays. Here we use the function name int. Now in statistics or discrete mathematics, we have an operation like a set operations whereby we have union, intersection. Intersection means you find the values that is in common in both items, both sets. So set A intersect set B means all the elements that are common in both sets. Now set A union set B means you want all the elements in both set A and set B, but you don't want a duplicate. So if we have the same element in both sets, we pick only one. The same idea here, because the question said we should find a common value between two arrays. So let's assume the two arrays are two sets. And now we look at it. What values are common in both of them? We print it out. So the first thing we did is to generate a random value. Here we are making sure that we can see that the values that are generated is a whole numbers. And also it's not decimal values between 0 to 1, excluding the 0 and 1. So for example, if I say np.random.random, then it will generate all values between 0 to 1, but excluding the 0 and 1. Here we want to generate values, a whole number here. So here we use the run int. Run int means sure integer is a whole number. Int means a whole number. So run int method will generate a random whole numbers between, again, 0 and 9. So this means we use the run int method to generate those values. Here we say 0 to 10 and 10. Same size here, between 0 to 10 and 10. So it will generate any random numbers between 0 to 9 and 10 numbers. So when we generate the two items, we put the first one in Z1, the second one in Z2. So now we use the function called intersect 1D, because our vector one dimension. Intersect 1D, Z1 and Z2. So this function will look for the common values in Z1 and Z2 and print it for us. So in this case, it's 4689. So the main work is the intersect 1D. Now, next, they say we should consider a generator function. And this generator function will generate 10 integers and use it to build an array. Again, integer means whole numbers, So our function name is called generate. Now in Python, to come up or write our own function, we start with the keyword def, then the function name and its argument. So in this function, we said we are using for loop. X is our counter variable. So we say for X in range 10. So because it's 10 integers, 0 to 9, 10. We are going to yield X. X is our counter variable. So the first number is the second number. It will go through until we reach the whole 10 values. So the question here now says we should use the function to generate 10 integer. Then we are going to use it to build an array. So we use this for loop and we again yield X. Then next we use the np dot from iteration, or I'll say from intel. Remember, for loop is iterating. So from intel, we use the generate function, and the data type of the function we said is float, and also the count is equal to -1. Now we assign all this to our Z. So the Z is our array. Then we print the content of Z. So we can see the values we have from 0 again to 9 with period between. Next, we are going to create a random vector of size 10 and sort it. So since we are going to create a random vector, size is 10, we can just use the random.random10. Then we use the sort function to sort it. So when we call the sort function, we don't need to have the np.sort, because sort is a static function. Maybe I can use that term. We don't need to use the np, the NumPy. So z.sort, after we sort it, we print. Now we know the random 10, it will generate a number between 0 to 10, excluding the 0 and 10. So all these values here again are between 0.011 to 0.999 something. So we sort it so the lowest value comes first before the highest values. Next, we're going to create a random vector of size 10 and replace the maximum value by 0. So after we create a random vector, the size is 10. So we're doing the same thing, np.random.random10. Now we say we want to replace the maximum value with 0. So we assign 0 to what? The Z have all the random values we generated. So we say z.argmax. So argmax will give us the maximum value. And we assign 0 to it, to the maximum value in there. So you can see here we are using the square bracket. So this is like the index, the position of the maximum value. We assign 0 to it, then we print it. So the 0, we have 1 0 here. So this position should be the maximum value. So next is, how do we multiply a matrix? We use the NumPy array by scalar. As we said earlier in the lectures, a scalar means one single value. Matrix can be any size, rows and columns. So example given here, they say given a NumPy array matrix, how to get a NumPy array output which is equal to the original matrix multiplied by a scalar. So let's say example here, we create an array, we say np dot array, and the array have an element 1, 2, 3, and also 4, 5, 6. So what we are doing is that first we create our array, we put the array in a content name A, or I'll say a variable name A. Then we multiply 2 by A. So what we are doing is that 2 is a scalar. We multiply 2 by A. And if we can remember the lectures on matrix, we did previous lectures, we say when we multiply a unit value, a single value by a matrix, we are going to multiply that value with all the elements in the matrix. So in this case, our answer will be 2 times 1, 2, 4, 6, 8, 10, 12. And that's what we have here. So anytime we multiply a scalar or a value, a single value by matrix, again, we multiply that value with all the elements in the matrix. Next is the identity matrix. I think we saw this example before, and we are using again the I function. The previous example was I3, which creates identity matrix. The size was 3 by 3. Again, identity matrix means on the diagonal section, the values are 1, the rest are 0. Here is 4. So we have 4 by 4 matrix, 4 rows, 4 columns, with diagonals are 1. Next, also we talk about the array data type conversion. We can always convert. So let's say we have an array here. We can see our data is decimal values, or double or float decimal values, 2.5, 3.8, etc. Now we want to convert it to integer, a whole number. So what we do is that we use the A is the content. A is the content of the, I would say, the matrix or the array items here. So we use what we call the as type function. So we say A dot, because A contains the content of the array. So A dot as type. and then we specify the type as an argument. Here we want to convert it to int, a whole number. And when we finish, we assign the result to a variable named 0 or O, sorry, it's named O. Remember, variable name cannot be a digit or cannot start with digit. So this is O. So we print the O, and we can see that 2.5 become 2, 3.8 become 3, 1 point. So we are removing all the decimals. We are not going to approximate it. We are going to remove it. So that will be the output here. Next also is how do we obtain Boolean array from binary array? So here we are going to convert a binary NumPy array, which contains only zeros and ones, to Boolean NumPy array. What we mean here is that we know, for example, in C++ language, true means 1, false means 0. In Java, true is true, false is false. In Python, also the same concept, the data type. We use the bool. So for example, here we have an array, the name is A. We create the array. You can see all the values are 1, 0, 0, or 1 zeros. Now we want to change the data types to bool. Bool means it's going to take only true and false. So anywhere we have 1, it represents true. And anywhere we have 0, it represents false. So here we use the same thing as type. As type is always used to convert the data type. So the content of the array is in a location named A. So we say A dot as type bool. Then we print, then we assign the result to a content name O, or let's say variable or array name O. Then we print it. So we can see our result. Anywhere there's 0, it turns to false. Anywhere there's 1, it means true. Now we come to the matrix multiplication, and we did the lectures on this. We said in order to do matrix multiplication, the first matrix on the left, for example, this matrix, the number of columns must be the same as the second matrix, the number of rows. In this case, we have square matrix, 3 by 3, 3 by 3, so we know we meet the condition. So this is our first matrix. We use the np.array to create it. Our second matrix is in B. So to multiply, we use the at sign. So A at B, we multiply the two matrices. Here we are going to get a result. So we print 0, and this is the result here. Because the first matrix number of columns is the same as the second matrix number of rows. So we get a result. Now, if you are running this program in your Jupyter for practice, try to change the size of the matrix, and you will see if the condition of the first matrix number of columns is not the same as number of rows, you get error message. Next is the matrix transpose. Again, in the lectures, we said to transpose a matrix is to change rows to columns, just to convert. So here we have a matrix. Again, we put the content in A. So we have matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 by 3. And we call, we are going to transpose it. We use A dot T. Then now we put the content in an area name or memory location name A underscore transpose. So we print it, and you'll see that instead of 1, 2, 3, it will be 147. And so in the here we have a column 147, it becomes a row 147. A column 258 becomes a row 258. A column 369 becomes a row 369. So again, a transpose of a matrix means to convert rows to columns, etc. Next, also we can find a sign of an angle. This is one of the advantages of a NumPy package. It gives us the trigonometry functions. So example, here we have a array name angles, and we use the array function np.array to create it. It's in radians. So we can find the sign of these angles. All we need to do is use the sign function np.sign and the content of the values. And when we print this, we get our output here. Same thing, we can find cosine. We use the function name cos. the function name cos with the content as the argument. The content of this array is inside a location name angles. Then we print it. So that will be the conclusion of these lectures. Again, these lectures cover not everything, but we cover most of the NumPy method that, again, we can be able to use in our program. So again, wish everyone the best, and hopefully everybody can solve their week 5 assignment.